What's going on, guys? Sorry about that. Sorry about that. Make sure you guys just forward. I'll try to cut off the unused portion. But what I wanted to do, Terrence Howard is taking the world by storm with his proposals, with his inventions, with his patents, with his speaking engagement. He's been spending decades and decades preparing for this. I was amazed that we hadn't heard anything too much about it prior, uh, but he was laying the groundwork. So it tells you how intelligent he is, how much of a tactician he is. Uh, so we're going to go through some of his theories on here, excuse me, and some of his actual proposals. Um, and we're going to compare them versus what we're doing now because I actually support them, most of what he's doing. There are some things that may be a little bit of kind of weird, but other than that, Terrence Howard, you know, we're going to go through some of this. And you guys make sure you comment on here. Let me know if you want more information on this channel. This is going to be important. We'll go through some of the controversy that he's been stirring up. And some people just can't get it in their head, can't imagine. But I actually see what he's saying. I see what he's doing. And it's very necessary. I'm going to go through some of this stuff, and we're going to try to actually do it kind of quick. But, you know, we'll try to do it as fast as possible. But we want to get through this in a manageable length of time. Make sure you guys press the thumbs up button on here. Make sure you share this message and let me know what you're thinking here. All right. Peace out to everybody who's up in the chat. Peace out to everyone who is on X over there. Make sure you like this, and just retweet it. Retweet it. Send it to your Facebook. Send it to wherever. All right. So let's look at this. Terrence Howard. So look, but actually before I get into that, let's touch on this one story. I did want to do because this is the Science Channel. On this, they did find some water in the planet. Okay, so not just the water. We have our planet is covered in 3/4 water. So, most of the most of the top of the planet Earth is water. We got water all in the atmosphere, but they're finding now 400, not just 6 miles, 10 miles. 400 miles, 430 miles beneath the ocean, they've discovered an ocean, and they're saying that it's actually 3 times as much water as we have on the surface is inside, at least 3 times. That's what they're saying. So let's look into that real quick before we get into the main topic of Terrence Howard. Like I said, guys, make sure you retweet it, press the thumbs up, and like I said, let us know whatever your thoughts, good, positive, negative, it doesn't matter. Put your thoughts out. That's what the internet's for. And let me share this here. Hold on a second here. Hold on. Let me get back into this here. There it is right there. Let me share this. All right. So this is on Smithsonian Science Education Center. All right, so they're basically saying, is there an ocean below your feet? Some scientists think Earth's oceans formed when icy comets hit the planet, but new research suggests a different origin for the oceans. They simply seeped out of the center of the Earth. The finding published in Science suggests that the reservoir of water is hidden in the Earth's mantle. It's in the fires, under the fire, more than 400 miles below the surface. Try to refrain from imagining expanses of underground seas. All this water, 3 times the volume of the water of the surface, is trapped inside of rocks, they're saying. So, a piece of synthesized ringwoodite, the blue mineral that may contain oceans worth of water in the Earth's mantle. So basically, they're saying it's rock. The water is infused in the rocks. So called ringwoodite, the rock is bright blue and is only formed at high temperature and pressure in the Earth's mantle. The water would have been squeezed out of the rocks almost as if they are sweating. Stephen Jacobson of Northwestern University told New Scientist. This research adds to our understanding of the complexities of the water transport throughout the sky, across the oceans, and into the ground from the editor's summary of the study in Science. Okay. So the water cycle involves more than just the water that circulates between the atmosphere, oceans, and surface of the water. It extends deep into the Earth's interior as the oceanic crust subducts or slides under adjoining plates of crust and sinks into the Earth, carrying water with it. The team of scientists used seismometers to measure the motion of energy waves caused by earthquakes through the ground below the United States. The waves slowed down as they passed through the region of the mantle containing ringwoodite. The scientists suggest that the saturation of ringwoodite with water explains the sluggishness of the waves through this particular region of the Earth's center. So to learn more about this, and you can go to somewhere else to learn more about it. But I just thought that was an interesting thing. It just shows you, there's a lot of information that we don't know about. There's just a lot of information. I did a story a little while back about, them finding a region in space that contained. Listen, they said this region contains 140 trillion times the water of Earth. 140 trillion times of water that's on Earth. This is what they found in space. Which to me is very interesting because usually when you find actual water, then that's definitely a source of life. And I'm sure that's a source of all sorts of comets, whatever. Astronomers find largest, most distant water reservoir of water. So that's an artist's concept of it. But the astronomers, including the team, found a feeding black hole soaking in water vapor. So, a black hole can shrink the Earth, the whole planet, down to a space within 2 meters or what have you. I believe some people say even 2 inches, depending on the strength of the black hole. Of course, with the same amount of density, the same amount of actual mass. So if this black hole has that much water, just that's some serious business. Some serious business. So there's a quasar powered by an enormous black hole that steadily consumes a surrounding disk of gas and dust. As it eats, the quasar spews out huge amounts of energy. Both groups of astronomers studied a particular quasar called APM 08279 plus 5255, which harbors a black hole 20 billion times more massive than the sun. 20 billion times, and 1 billion is 1,000 million. So 20,000 million more times massive than the sun. And I think the earth can fit in the sun over 1,000 times. Yeah. Over 1,000 times. So yeah, we're talking some huge numbers. It just shows you, the majesty, the size of our universe. And it shows you how important it is to have precise numbers and calculations because, as we know, with calculations, they can get, when you start to get bigger, a little margin of error increases. Small margins of error when you start off something, it may be within estimations, may be good enough when we're dealing with small volumes. But when you're dealing with huge expanses, we have to have absolute precision in numbers. So this is where we want to get into what Terrence Howard is proposing here. So, brother Terrence Howard, now we're going to show him. He's an actor. The brother is an actor. So, of course, because of his profession, and because of his profession, because of everybody knowing him as an actor, of course, you're going to be very suspicious. You're going to be suspicious of him as a scientist. But this man has been doing science, when we start to look at this here, he's been doing science for way longer than we should have been known that he's been doing science. I'm amazed that nobody really knew. Well, the public didn't really know that he was this deep into science authentically. He's an authentic scientist, physicist, inventor, patent holder. I mean, and when he says that virtual reality is based off his patent, it sounds crazy, but he's not crazy. Now, some people dismissed his. Now, he's been doing an all-out media assault as of late, and it's very important that he went to. Now, he's been doing the media assault. He's been stepping it up actually over the past few years. But lately, he's been on Joe Rogan. He's done some other stuff. He's been doing white media mainly, but then he's starting to pepper the black people in, which is good. But I kind of understand he goes and deals with the white audience because they're the controllers and gatekeepers inside of the science realm of the science community, and this is where he's trying to get respect and basically, bona fide in that realm. So he comes out very controversial, but this is something to him is very easy. But what he's doing here, with the 1 + 1 = 2, 1 × 1 = 2, just something simple like that. It sounds very controversial, but he can actually prove it to you very easily. So I think that's why he led with that. But let's look at this here. I want to get into something this here. So let's go through about 6 years ago, they posted. So he did a speech in Oxford. So Oxford is very prestigious. It's supposed to be one of the more prestigious places of science, establishment, the credit, the academicians and stuff like that. This particular speech was posted at least on YouTube 6 years ago. I'm imagining he did it 6 years ago, but we don't know. So let's just look at it. We're going to skip through it. It is about like an hour and something long. Of course, we're not going to look at the whole thing because I am just trying to get through some of this here just to give you guys some points of reference.
Wow. I know we're starting a bit late. We're trying to get some stuff loaded up that we won't be able to use, so we're going to do it a little differently now. We're going to do it manually.
So he had props, pictures, and things like that here, but he was not able to load it up and use it. So he's just going to speak. He's just going to use his talent as an actor, as a presentation person to speak his theory. Now, first question. Now, you guys can go watch this. We're going to look at a couple pieces of it. But first question here, like I said, this is the real Oxford. You got to ask yourself, why would they allow him to speak? He's a nut, right? Isn't he crazy? Isn't Terrence Howard just an actor? Shouldn't we dismiss him? Obviously not. Obviously, they're not dismissing him. Why aren't they dismissing him? This is like if you pay attention to some of the other movies. Was this that movie? The one with Jamie Foxx he did with the old racist way back in slavery times, and anyway with Stephen, But the point is, he's not being dismissed. He's being respected. Now they're questioning him. They do question him. Let's get into a couple. Now he's going to show this point. This is a good point for us to look at. He had this paper. So let's look at this part. This stuff people call pseudo in our community. See, and the thing is, to me, our brains have been limited because science is not about just believing and following orders. Scientists have been killed because they have broken out of that system. They have questioned. Science is about proving, challenging, and proving. This is a systematic thing. Anybody can do the scientific method. Anybody can observe. Anybody can ask a question. Anybody can come up with an idea of why, hypothesis. Anybody can make an experiment. Now, of course, being trained, you're going to have a better quality experiment. Of course, your experiments, this is where the academy comes in, a trusted, systematic way of doing it, which is very important and very necessary. But you can come up with if it's fair, you can create an experiment, you can come up with a conclusion, and you can get a result. You didn't have to go have your degree. Now, your degrees from the school, if the school is relevant and in line with the universe, because the university is supposed to be a small universe. If their methods are not lined up with what we see in the universe, then it's not precise. So let's listen to what Terrence is saying. This is his philosophy. This is what he's doing. This is what he's saying. So let's look at it.
In nature. You show me where the platonic solids come from.
Hold on.
Where do they have their... Well, apparently, there were secrets inside of it.
Hold on. Let's see.
Cyrus in Egypt. This one little thing called the flower of life. Now, do you know the flower of life? Have you guys ever seen this before? Now, this is one of the oldest symbols in human history, right? Or do you not know? This symbol was found in the Temple of Osiris in Egypt, and it had been molecularly burned into the wall. And it's 6,000 years old. This same symbol has been found in the forbidden temples in China, sitting under the fufu dogs. And the foot on it, the flower of life, saying whoever controlled that flower of life controlled the universe. There were secrets in that flower of life that Da Vinci spent his whole life trying to uncover. There were secrets in that flower of life that Newton spent his whole life in secret trying to uncover. The same secrets that Pythagoras was desperately trying to uncover. But the problem was they kept seeing this in a two-dimensional space. They couldn't get it out of this two-dimensional frame, and as a result, they got stuck in this plane, a flat plane. Now, what Da Vinci and all of them wanted to do, they were trying to find a way to bring this flower to life, because what is inside of it? Well, apparently, there were secrets inside of it. Shapes, they got the Merkaba and all of those other things out of it. But they were misled by something I think called a straight line. You guys believe in straight lines? You believe there's straight lines in the universe? Well, let me hit you with something. All energy in the universe is expressed in what? It's in motion. If something is still, there's no energy. Kinetic, right? All motion is expressed in what? You look at galaxies, are they expressed in straight lines? Expressed in vortices. All vortices are expressed in what? Waves. All waves are curved. Show me a straight line in nature. You show me where the platonic solids come from. Where do they have their foundations in our universe? Are there any straight lines? If you look at anything, there are no straight lines. That's been the mistake. We've been looking at these straight lines, this Euclidean way of thinking, and missing the curvature of nature. So here we are, back with the curvature of nature. And you have all these little pieces. Now, this has always been an information system. So compare some of these points, take a point here, and say, well, what's the space in between all of these things? Now, they've said that all the in-between spaces, if this is the Earth and this is the moon right here, all this in-between space is filled with what? A void. There's nothing in the void.
So let's go through a little bit of this here. I want to go through just a little bit of this here, because see, what happens is, if you're not familiar with any of this kind of talk, which is very purposefully done, they purposely mix and match who they educate with certain information. And so that you're lost. That's almost like putting a 5-year-old who's never been exposed to, division, multiplication, algebra, trigonometry, geometry, calculus, pre-calculus, calculus, and logarithms, and they've never been exposed to that stuff, and you just throw them up there in logarithm, and they don't understand. And then even if they understand some of it, it's too much being thrown at them at the same time, and their brain starts to hurt, and then they just get irritated. So this is the reason why. So these are some of these shapes he's talking about. Now, the platonic solids, though, I'm just going to read some from a book here that I got, and let me see if I can even show this book. Man, I don't think I can show it on here. Let me see. Let me do it this way. I think I can show it. Hold on one second. Let me get to my page. I have to show it through my phone. Y'all just bear with me for a second. All right, so let me see if I can show it through here for y'all so that you guys can see this. I gotta log on to here this way. Yeah, and like I said, guys, make sure you guys press the thumbs up, retweet it. Let me know what you think. You think Terrence Howard is crazy? There's no way that, 1 times 1 could be 2. That's impossible. You guys got to realize too that before the Europeans got exposed to before they got exposed. Hold on a second. Before they got exposed to certain numbers, they were using Roman numerals. And Roman numerals, are a different way. Let's try this. So the systems of maybe it's this one. Yeah, so the systems change. Systems don't always stay the same. This is what people don't understand. And so if a better method of doing something is found, then they just change the method. Everything else has to change though. Above that, that's the issue. That would be the issue. But it's a different way can actually be done. It's not out of the question that a different method of making calculations could be done. This is what a lot of people can't even get in their mind. I don't think I'm gonna be able to show this. Anyway, I'm just gonna read it. Yeah, don't worry about this. I'm just going to read this. So the platonic solids came from Plato, 428 BC. He was a Greek philosopher. Plato did a lot, so we're going to read about him on some other stuff, on the religious stuff too. He's actually the one who came up with the ghost god. So there's a god, most of gods have physical form, anthropomorphic god. People were God. Plato's one of the ones that came up with the God as a ghost thing. That's immaterial. But anyway, so a platonic solid is a convex, multifaceted 3D object whose faces are all identical polygons with sides of equal length and angles of equal degrees. Hold on 1 second. Let me get you guys a picture. This is Terrence's stuff. Let me find you guys a platonic solid here so that we can have some visual with this. Let me get you guys some. There it is. Let's try this then. All right, so let's do it this way so you can see it. All right, there we go. So let's do this. Let's read it. A platonic solid is a convex, multifaceted 3D object whose faces are all identical polygons with sides of equal length and angles of equal degrees. A platonic solid also has the same number of faces meeting at every vertex. The best known example of a platonic solid is the cube, whose faces are 6 identical squares. The ancient Greeks recognized and proved that only 5 platonic solids can be constructed: the tetrahedron, the cube, the octahedron, the dodecahedron, and the icosahedron. For example, the isoconahedron has 20 faces, all in the shape of equilateral triangles. Plato described the 5 platonic solids in Timus in around 350 BC. He was not only awestruck by their beauty and symmetry, but he also believed that the shapes describe the structure of the 4 basic elements thought to compose the cosmos. In particular, the tetrahedron was the shape that represented fire, perhaps because of the polyhedron sharp edges. They thought some other stuff. So I ain't going to go through all that crap. But the point is, this is what the platonic solids is. When he's talking about platonic solids, we need to have that in our head. See, like I said before, they make sure they stratify their education, and it's not everybody's fault, because a lot of people call someone's crazy, and because they just don't know. They don't think to question stuff, because that's just how they were educated. So, they see this, and they remember, oh, this person was an actor, and we can't take him seriously. We've been trained not to take him seriously. Doesn't matter how many facts he puts out. So he's going through this thing called the flower of life. We'll go through some more of that. I want to get to he does the speech. You should watch this. It's on YouTube. It's Terrence Howard at Oxford. But he does a speech about mathematics and all this stuff, his inventions, his patents. When the students get up to question him, of course, they're just questioning him about acting, because that's what's in their head. But a few of them do question him about some of his proposals here. That's when he stands up. See, the acting is just something he can do, but the science stuff, this is actually Terrence Howard is. This is who he is. This scientist, this mathematics person, this is actually Terrence Howard. The actor is the second-hand guy. So a lot of us, we're used to looking at this guy as an actor first, but actually he's an actor second. That's just to pay the bills. This stuff that he's been doing here with all of this science and invention and all that stuff, that's actually him.
Gives us money based on that evaluation. Is that fair?
Hold on a second.
Get the universe to work for you instead of using just the solar rotation. Panic is headed to an iceberg over there with our numbers. If we don't make a change soon.
Okay, so that's a part I did want to.
The Dewey Decimal System and said that it was wrong and created an entirely new system to show how it can be brought into correction. So I'm not the first person to.
Okay, so listen to that point right there. See, so people who are saying what can't be, he's proposing a new system of calculation. It's not really that new. He's just making the system that we already have more precise.
An audit, you're proposing like a
I'm not the first one to
of
say
the way we
need to do
understand
this.
math.
You know what's interesting? In 1856, a man from Liverpool named Richard Dover Statter challenged the Dewey Decimal System and said that it was wrong and created an entirely new system to show how it can be brought into correction. So I'm not the first person to state this. It's a number of people did it, but look up Richard Dover Statter. Try and find him. You won't find him because he's been erased from history almost. But what is the thing called, honey?
It's called the decimal something.
Dewey Decimal System as a whole. The Dewey Decimal System as a whole. And you will see that the Titanic is headed to an iceberg over there with our numbers.
So let's look at this. We're going to look at his numbers real quick. So let's listen to her question first, though.
need to tear the human body apart when all you can do is use frequency.
Actually, I gotta let him. This question. I want us to hear this one. Okay. So he stands up because he doesn't have these props.
Thank you very much for talking to us. And also, your view on consciousness and energy sounds very similar to what Dr. Robert Lanza proposes in biocentrism. So that may be of interest to you if you haven't read that text. But about 5 years ago, you spoke about harmonic wave sequencing. And
so listen, this talk is 6 years ago. I want y'all to think about this, especially the black people who call Terrence Howard crazy. This particular talk at Oxford is at least 6 years ago. This guy who is a young white guy at Oxford, he says he heard a speech by Terrence Howard 5 years prior to that. And he's talking about harmonic wave resequencing. So these academics have been paying attention to Terrence Howard. How come we haven't heard about this? This is all we've seen of him. This is all we knew about Terrence Howard. We amazed. We laughing at him. You have people on the internet saying Terrence Howard is a fool. And if you listen to him, you stupid too. Terrence Howard on some old-ish from humiliation ritual. That's what SETI is talking about, just because he got his hair like this. We're going to see why Terrence Howard's hair is that way. Is it the same reason Diddy's hair is that way? No. I just want y'all to see that. But let's listen to this answer. This is a very important answer to pay attention to if you're trying to understand what this guy is actually putting out here.
And how that could
Harmonic.
Make sure you retweet it, press like, press share. Let me know if this is an interesting points. If you have any thoughts, good, bad, ugly, don't matter. Put them in.
Wave resequencing.
Resequencing, and how that could possibly solve cancer or genetic ailments within the next 5 years. I think that was about 5 years ago. So is there much progress on that? And how do you propose that this resequencing would actually recode people's genetics in order to prevent them from getting these ailments?
Simple.
That was a joke from the white guy. This is satire. They're making fun of him in an intellectual manner. But notice he stood up because he recognizes the challenge. And watch him.
Our DNA is made up of what? 5 elements, right? Hydrogen, carbon, nitrogen, phosphorus, and oxygen. Do you know how they're arranged? The phosphorus sits right here in the middle, and you've got 4 oxygen atoms surrounding it. Then there's another phosphorus, 2 more oxygen atoms. Now these are the legs of that double helix. These are the legs. Now
keep in mind, Terrence Howard just got asked this question. He doesn't have a prop. He doesn't have any notes. He knows this. Okay, so he's thought about this. He can teach this.
the latter steps on it, they become the adenine, the guanine, the cytosine, and thymine, the ATCGs. It turns out hydrogen, they used to think that energy, the body transferred or understood the energy information through electricity. They're finding out it's through frequency. Well, guess what hydrogen sounds like? It's a key of E.
That's the key of E. Now, I'm just giving y'all, this is stuff that you can look up. I looked it up and I'm just putting it in where he says it. But these are things that he's studied. Now, do we know if it's true or not? See, because actually to do this here, See here, this is what the guy is challenging him on. See, to do this, you observe something, you question it, you create an idea, hypothesis, and which is, harmonic resequencing. Now, to do this part, the experiment, okay, now it takes. So the guy's asking him, what is the progress on this portion, the experiment? This is where the money comes in. You need some money, you need waivers, you need all sorts of legal situations to get to this point and to do that experiment. So right now he's, so this is kind of where the big bucks come in. This is where the establishment comes in. Those last three of the scientific method. But let's go back to it. But they've actually done this. You can run sound. Actually, I should have pulled up the video, but you guys know if you put sugar, you put sand, you can put sand on like a drum, or you can put it on a flat surface. If you just put a speaker in a certain sound on those small grains, you can put a speaker. Let me see. I'll try to see if I can find it. But you can put a sound on those small grains. A certain frequency will actually reshape those grains. It will create a certain shape. Each tone will create a shape in those grain, in those sand or rice or whatever it is that you want to put on there. The vibrations, the frequency. So this is not just some silly stuff. So I'm just showing you, because a lot of times we hear stuff real quick, and because we don't understand it, it sounds crazy. But I'm just giving it to you guys like, no, this stuff that he's talking about is the reason why they're not laughing just outright like that is because it still sounds crazy to some of them, but he's backing up his theory.
Guess what? And it's the color yellow. That's what proper physics gets you to. Oxygen is a chartreuse, and it's the key of F over F sharp. Now, they used to, like I said, information used to be thought about as just electrical information passing on. But I've got to...
Now, let me play that key. Now, let me go through what he's talking about one more time here. See, you see these here, he's talking about the DNA. He's saying that each the spot, and you see how, and notice how the shape of these bonds are in like a 2, 3, 4, 5. It's like a pentagram. It's like a pentagram shape. And this is how the bonds of DNA of molecules do. This is just how they connect to each other in nature. So when you see the pentagram, people talking about it's evil. It's evil. No, this is how nature works, guys. It's not evil. This is how nature connects to each other. Okay, but he's talking about that phosphorus in the middle, that P, and then surrounding it is oxygen. And so these are basically their belief is if you can put a certain sound, that it would help the DNA resequence itself, because sometimes the DNA gets damaged. Okay, so that's this theory that he's explaining.
Question for you. Have you ever been at a party with some of your friends you ain't seen in 10 years, but y'all was like 14, you hung out and there's a song that came on and you was like, and everybody got up and was live at that moment. Now say 10 years later you got a friend with you. He's a good guy, but he wasn't there when me and my boys formed this. So when that song comes on, our DNA tightens. There's a particular song, a scale in the genomes for each and every one of us. Now, when that song is played, when your particular prime resonant frequency is played, guess what happens? Your DNA celebrates and tightens. Everything else gets pushed out. harmonic wave resequencing. The carbon is also the key of E and yellow. The nitrogen is G. And all these play a song. So say that the F over F sharps of the oxygen, the green, is only hitting at an F. Why? Because there's another frequency coming in from a generator over there. That's changing and causing it to change. So this F now hits the oxygen, and when it hits, the F hits the carbon, so instead of hitting as an F sharp, it hits as an F, so when it hits the carbon at an E, it doesn't hit it quite right, so the domino don't file right. So the next domino hits wrong. And so now we have malformation happening within our DNA because the frequencies are being pushed off. But when we hear our tone, we tighten back up. So yeah, I'm in the process of building the harmonic wave resequencer with another doctor who has been able to successfully cure AIDS and cancer. And it's well underway. But I wanted you guys to understand how that works. It's so simple. You do not need to tear the human body apart when all you can do is use frequency to bring it back to its normal space.
All right, I just wanted to show y'all something here with that. Just so y'all can see, like I said, make sure you guys press the thumbs up. That's very important for the channel. Let me know that what content. Make sure you go through some of the content on this channel. Give me some reviews on some of the content, or some ideas on it. That would be helpful for this channel. I actually need to put more content on this channel because I do think of these type of subjects more. But I want y'all to see this here, just so you can see, just in case people weren't aware of this kind of information. It sounds crazy. So let's look at this.
The first experiment for the cymatics music video is called a cladding plate.
But did you see that? That's the main part I wanted to show. I don't know what they're talking about, but yeah, the cinematics. But you notice how each sound actually moves. Now, sand is much larger. A grain of sand is immensely larger than a piece of DNA. Way larger. Okay, it's larger than your cells. It's insane. All right.
The first experiment for the cymatics music video is called a cladding plate. A cladding plate is basically a metal plate attached to the top of the speaker. There's sand on top of the plate, and you play different tones through the speaker. The plate vibrates, which forms different shapes depending on the frequency of the sound.
Well, we blew up a lot of speakers with the Calamity plate. So there was a lot of experimenting around the Calamity plate, primarily looking at how much volume we can put through there, how much sand to actually put on the plate, and the different shapes of plates and what different patterns would be created because of those shapes. But what we were really testing was what frequencies create the most interesting repeatable pattern, because that was a key point. So we ended up playing pretty much every audio frequency through the plate to see what different shapes it would form.
And for most frequencies, it doesn't really do much, but when it hits a frequency that resonates with the plate, it forms a really nice pure shape. So we found out what those tones were, and those were the tones we used to draw the plate in the video.
Ain't that cool? That to me is very cool. I think that's it. The thing is, see, that's what a scientist would figure out. Like we got to do something with that. When you find something like that in the universe, that is, that's a feature of our universe. So that's a discovery. So if it's a feature of the universe, this is part of the formation. It has been used to form structures before. So that right there is something important to know. So like I said before, so let me get into some of this thing here, some more of Terrence Howard. I want to hear this girl's question, and then we're going to move on from that. I want to go to his website real quick, and then I think we're going to end it off.
Great. Thank you for that question. Yeah, let's go to you.
And keep in mind, this is 6 years ago.
Thank you so much. I've always been interested in acting, so it's pretty cool to be in the presence of an actor. But my question actually has to do with your numbers theory. So if by your logic you say 1 times 1 equals 2, are you insinuating that 1 times 0 then equals 1?
Equals 1. Well, that's what we were saying with the identity principle, the identity property. It says that 1 times nothing equals nothing. Something, so now you have the laws of physics have to now adjust because something just disappeared. Conservation of energy, energy can't be created or destroyed. So if 1 times 0 equals 0, then what happened to the energy of the 1? Isn't that the same problem that Stephen Hawking was talking about with the event horizon and the information going in and still being present? That conflict that was started? Well, that's because of the math. The principles in the math are not founded on truth. It's not founded on substance. The identity principle, anything times 0 is 0, and anything times 1 is 1. Where is that number? Where is that exemplified in nature or in universal phenomena? Is it? Do you see that?
So then, are you saying that 1 times 5 would be 6?
Yes. Well, what does it say in the associative and commutative thing?
So you're
if A and B
proposing-
are positive integers, it says if A and B are positive integers, A is to be added to itself as many times as is indicated by units in B.
So you're not proposing an audit, you're proposing like a
Well, I'm not the first one
reconstruction
to
of
say
the way
we
we
need to do
understand
this.
math.
You know what's interesting? In 1856,
So let's look at that. She got it. Now the thing is, basically her argument is it's too cumbersome to even try that. No, this is what it needs to actually be, because let's look at it. Let me see. I'm gonna share this here because I did a little bit here. It's actually more in line. What he's saying here is actually more in line with what it makes sense. The way that we do even to the basic numbers. This is what he was talking about in precision and accuracy, especially with universal. He's going to make a couple statements that back up his claim, but let me see if I can. Where is this at? Okay, here it is. Where is it? I think it's here. Let's try this. Okay, so I did this here. I think y'all can see that. Okay. So right here. So the definition of multiplication, and we can do this here though. We don't have to look at this. I have it here. So this is what multiplication means. Now, people are like, well, just change the definition of multiplication. Well, no, because the definition is correct. It's what we're doing here is not lining up with actual reality. See, the way that we've been taught multiplying is okay. So we say 1 times 1, it means one time. That's what the way we've been taught. We had to be taught that it means one time. Okay, but what multiply, it is an action. See, it says multiplication. Multiplication, any increase in size, number, or amount, act, or process of increasing in number. Okay? That's what it means. So when you say this word, you define it as this. This is a mathematical action. Now, this is something that you go out there and do. But oh well, when we see one, we're not going to do it because it's gonna. We don't. We're gonna. It's not. We just don't want to do it that way on one. But on two, we'll use it. We'll start to actually multiply. It doesn't make sense. No, what he's saying is if you have one, and then you multiply what you already have. Let's say you had an apple. Let's take one away. Let's use one as an apple. You have an apple. If you multiply your apple 0 times, you just have your apple, but you don't do anything with it. You take no action. You multiply it no times, meaning you take no action. Did your apple disappear? No, it doesn't. That's what he's saying. So what he's saying is the truth is if I have my apple and I take no action against what I have, then I have what I have. I have one apple. I have an apple. But if I have my apple and then I go act out in the universe and I'm going to multiply one apple one time, I'm going to get one more apple. So now I have 2 apples. So 1 times 1 is 2. And it would resequence in order to get your 0. 1 or whatever the number is, let's say 3. You have 3 apples. You're going to multiply 3 to get 0. You would have to say 3 times -3. That will give you 0. If you do 3 times 0, it's going to give you 3. You would resequence that whole thing. Also, so if you look at this, this is what he's saying. You resequence all those numbers. I don't know if we can even see this here. But anyway, I did just a little table there for anybody who wants to look at it. So basically, you go through here. If this is the zeros, if you multiply zeros, that's the only time you get zeros all through it. Zeros don't turn everything else to 0. Also, now if I divide something, a division is a cut. So if I take a 2 and I cut it 1 time, then I have 1 on this side, 1 on the other side. If I take a 3 and I cut it 1 time, I have a 1.5 on one side and a 1.5 on the other side. If I cut that 2 times, then I would have 3 pieces. So I would end up with basically 0.33 or 0.66, whatever it is. So that's how you would do that. It would line up. It would readjust the entire foundation of the mathematics. It would get it more in line with what's actually true. And that's what he's saying with that. So, it is what it is. A lot of people don't like it, which I understand. But if you think about it, it stays on you. You realize that it's very possible to do, and it's not actually crazy. So that's all. All right, so let me go to his website here. Actually, let's see. Okay, right here. I think this is his website. So, and he leads with the controversial. This is his website. Let's see if you guys can see it. Make sure that I'm not. Okay, you guys can't see it yet. Hold on a second. All right. Oh, actually, you know what I'm going to do? I'm going to show you why he has this hair. For anybody who... He did an interview. Terrence Howard did this interview just a few months ago, 1 month ago, with Daphne Wynn. This was an excellent interview, and you should look at it. He gets into a lot of stuff. Of course, we can't go through the whole interview. I mean, but this part right here is going to answer why he has his hair this way. Keep in mind, he does act. He is an actor. Well, let's do it.
Really quickly, because I know most people want to hear a couple things about what you're doing with the wig, why we're here, we're on set.
This ain't no wig.
And that's your hair. That's what your hair.
Oh, this kind of like Richie's hair. This kind of like.
That's exactly what I was thinking, right?
Yeah, no, we're doing the film, and I thank you guys for coming.
Absolutely, thank you for having us.
Taking the time. It's me, it's Kevin Hart, Don Cheeto, Sam Jackson, myself, and a number of incredible actors. But we're doing a thing called Fight Night, and it's a night that Muhammad Ali fought Jared Quarry, you know, and there's a little robbery that takes place.
There's a little robbery.
Just a little.
Who's on the robbery side?
I don't know.
Somebody with a wig on.
Bad people. Everybody got a wig on. Everybody got a wig on.
So what's your character's name in this movie?
It's Cadillac Richie.
Cadillac Richie.
Yeah.
Okay, Cadillac Richie.
Yeah, Cadillac
Okay.
like that.
How is this different from any of the other characters you played?
I think Cadillac is a bit of a sociopath.
Oh wow.
I've only played a sociopath, I think, once in a movie called with Andre 3000, Ottawa. You see, I've watched you for a long time, Spence.
So this is like I said, this is the reason why he has this hair. And that's, because like I said, people don't understand this man actually is a scientist, but he can act. He can act. And so that's his that's part of him as well. So she came on set and he decided to give her the interview. This interview was actually super good. You should watch it. He goes through a number of subjects, of course, through the acting stuff, and it goes through some other stuff. But that's not all actually what we're focusing on here. But it is a pretty good interview. Let me see if there's another part in there I wanted to see.
Yeah, you're an actor. Why don't you keep acting? Why don't you keep acting? Because I have an entire generation that needs this truth.
Okay, so he's talking about his why, his purpose. So they go male, female stuff, and there's a lot of other stuff. Let me see.
Father, she lost her father when she was like 8, 9 years old. So my younger brother and Tony.
Okay, so that's his family stuff. All right, there's another part in here, but we're not going to really go into it. I just wanted y'all to see why he had that hair. All right, so this is a part here I want y'all to see. This is from the James Webb telescope. This is the current state of physics and astrophysics and stuff. Hold on, let me make sure.
And out from the crowd. The 5 galaxies observed by James Webb, the most distant of which is NGC 54.
Hold on. Okay, so remember he says
years after the Big Bang.
Hold on. I think it was this one. I think it's here. Right here. This is where I wanted to go. All right, so look. They're saying it's a big bang, right? It was a big old bang. This is where they taught us that the universe got started. Hubble, way back in 1929, he was looking through his telescope. He realized that the universe was expanding. He realized that certain regions of space was expanding. In his 1929 telescope now, he came up with this theory that, the whole thing is universal expansion. And then he did some calculations based on expansion nature of the universe that he's seen, the little parts that he's seen. And he decided to say that it looks like it's going to be like 13 billion years. And then it would have been a single point, right? And they decided to just run with that. And they haven't changed it since 1929. And they've seen hell bent to never change that or adjust that number. That is Hubble's number. It is sacred to them. It's almost like a little religion. That's kind of how they operate. Okay. It doesn't make too much sense to me, but let's keep it moving. So now this is the 13 billion years. This is what they're saying. So let's look now. This James Webb telescope, they just launched it a couple of years ago. They put it out. It's 1 million miles from the Earth. It's in a pocket away from the moon, kind of past the moon, where the moon is. And it sits out there. It's like solid gold mirrors, and it's got all sorts of gadgets. It's very more powerful than Hubble, which was the previous telescope. And they're getting some very interesting images. They're able to verify these images. I'm surprised they're so truthful, but I guess so many people are watching it. They can't lie to their whole scientific community because they have these true believers in there. So let's listen.
To publish a paper suggesting that, based on the new data, the universe could be as ancient as 26.8 billion years old.
So he's saying double what they're wanting to say. Now, why is he saying double based on the new information? Okay, we knew that it didn't make sense. 13 billion years didn't make sense. Did it? Never. It doesn't even sound right. A universe that's several million light years and nothing supposedly can propagate faster than the speed of light?
In astrophysics, the age of the universe. The Hubble Space Telescope was a huge factor in helping narrow down the scientific consensus on the universe's age. In fact, the telescope's mirrors were specifically made to observe stars called Cepheids that astronomers can use to calculate that age. The resulting measurement of the universe's age, about 13.7 billion years, has stood ever since. But let's not forget, there is another way to measure the age of the universe. That's with the cosmic microwave background, the light from the earliest phases of the universe. Using this method, scientists came up with a slightly larger number, 13.8 billion years. And while that difference may not seem huge, some estimates using Cepheids are as low as 12.8 billion years. Worse, no one knows where the difference comes from. It's like we're digging a tunnel on opposite sides of a mountain, and
So they don't know where the difference comes from. They're using light, okay, and redshift. Once it's stretched out, it can be going away from you, and it can just not bounce back, and you will never see it again. There are certain objects that is within sight now of what our position is, that in a few thousand years it would be out of our sight, and no one, if they keep the same tools and stuff like that we have today, they will never know that existed. So how much stuff has already ran out of our sight that that Hubble can see, that we can see now with these instruments, but how much stuff was there that we just never can see and never will be able to see because it's just too far. The light is stretched too thin. So, anyway.
we missed. Unfortunately, the surprisingly luminous early galaxies captured by James Webb did nothing to solve this mystery. In fact, the telescope's results led Rajendra Gupta, an astrophysicist at the University of Ottawa, to publish a paper suggesting that, based on the new data, the universe could be as ancient as 26.8 billion years old, about twice as old as current estimates. While the panelists agreed that Gupta's suggestion is extremely unlikely,
the panelists just agreed. They didn't say why. They just agreed. Now, Gupta said based on the data. But the panelists just didn't want to let go of that 13 billion years. Okay, let's keep it moving.
Discrepancy of the universe's age in general does suggest the standard cosmological model and our understanding of the impact dark matter and dark energy have on our universe may need some revamping. Put simply, it could be that something fundamental.
Dark matter, dark energy. Your calculations are off. You don't start multiplying until you get to 2. You do zero calculations, zero multiplying at 1. You know that as it gets bigger, that makes a difference.
Is missing in our current picture. What's notable, the impossible early galaxies aren't even the only things that keep cosmologists up at night. The Webb telescope has double-checked the work of its older sibling, the Hubble Space Telescope. Hubble's measurements of the expansion rate of the universe are exemplary. The trailblazing observatory found, further ratcheting up the so-called Hubble tension. Putting it simply, measurements of the expansion rate of the universe, defined by a property called the Hubble constant, just don't add up. On one hand, observations of the cosmic microwave background radiation, which is like a baby picture of the cosmos from just 379,000 years after the Big Bang, say the universe should be expanding today at a rate of about 67.8 kilometers per second per megaparsec. This means that every volume of space, 1,000,000 parsecs across, should be expanding at a rate of 67.8 kilometers every second. An alternative way to measure this expansion is by climbing onto the cosmic distance ladder, where each rung is formed by a different astrophysical milestone, such as Cepheid variable stars and Type 1 supernovas. How bright these objects are can tell us their distances, which we can then compare to their redshift values to determine how much the universe has expanded while their light has been traveling to us. However, the problem is, this method gives us a completely different value of the Hubble constant.
So you see, now you have this tension because they're using measurement methods and they're getting different conclusions, and they're checking, rechecking, double checking, triple checking, 1,000% checking, crowd checking. And the thing is, the math is wrong. Something's wrong with your math. Something's wrong with the methodology. So, and now what I believe, okay, let's just keep it moving. Let's go.
Somewhere around 73.2 kilometers per second per megaparsec.
Oh.
The apparent paradox.
Hold on. Sorry, guys. You couldn't see this. Sorry, you couldn't see this. Let me go back just a little bit. Okay, thank you. All right. Sorry you couldn't see this. Let me go back just a little bit just so you can see. But I think you could hear it, but you couldn't see.
Coming onto the cosmic distance ladder, where each rung is formed by a different astrophysical milestone, such as Cepheid variable stars and Type 1 supernovas. How bright these objects are can tell us their distances, which we can then compare to their redshift values to determine how much the universe has expanded while their light has been traveling to us. However, the problem is, this method gives us a completely different value of the Hubble constant. Somewhere around 73.2 kilometers per second per megaparsec. The apparent paradox between the two measurements is what cosmologists have started calling the Hubble tension. Nobody knows what is causing it, but some hypotheses call for new physics to explain the apparent contradiction. One possible explanation is that there is a measurement error on the bottom rung of the cosmic distance ladder, which is home to the Cepheid variables. These are stars with luminosities that predictably fluctuate as the stars pulse in and out. The longer the pulsation period between moments of maximum luminosity, the greater that maximum luminosity is. This period luminosity relation allows us to accurately calculate their distances to Earth. It's possible to measure the pulsation period to calculate maximum luminosity. Then, based on how bright a Cepheid variable appears in the sky to us. We can work out how far away it must be to appear that bright. But it's not quite a foolproof method.
All right, so we see that they have this problem. See, they're trying to make measurements. Now, keep in mind what's important. Why is this important? If you're developing star systems, you're developing all sorts of things like that. If you can't calculate where something's going to end up, you're going to kill everybody, waste everybody's money. So this is why this precision is vital. You can't play out here. Can't play. All right. Let's look at some more of what Terrence Howard says on not there. Let's look at it here. All right, so this is his website. And he goes into some of this here. These are his patents. This is his linchpin technology. But let's go through this one.
Oh, yeah. No, you got it. You're good. Let me share the screen here.
And make sure you explain about it being a part of the process. And that association.
So start sharing. Okay, so you can see my screen there. Okay, so this toroid is just there for a geometrical reference. It's not actually doing anything. It just kind of symbolically represents the magnetic field where it would be. Now on the right-hand side of the model here, I have two groups of vortexes, which are just like tornadoes, spinning tornadoes that are pointing towards the center. As I highlight this object here, you'll see it, that yellow line, right? So there's a bunch of those in there. There's actually 16 of them, and I'll highlight them all. There. Remember that, just so you can kind of see a little bit better. So they're all pointing towards the center, but they're arranged in what we call the linchpin configuration. I'm going to pretend like you never heard of that before. So there's one on the top, and then three in groups of three around that are spaced at 120 degrees apart. And the tilt of these ones on the bottom here is 109.5 degrees in relationship to the top ones. They're creating this flat space on the top and the bottom.
All right, so I'm just posting this just to show you guys that, the man is not crazy. He's very serious. He has actual technology. These are some of the illustrations of his, they show you the little videos. Now, some people have criticized that he's showing you the video AI illustrations, but he's got this is with your periodic table vortex. So we're going through that. Like I said, I just wanted to show some of the stuff that he's doing. I think I want to end it off with this here. Let's see. I want to end it off with some of the Joe Rogan stuff, but maybe I want to get some of the clips, the highlights. Let me just get to the point where he makes some. Actually, maybe I could just go to Joe Rogan's spot and just. There's just a couple of clips of this that I could shorts here. They make little small videos or something. Yeah, I don't know how to do Rogan stuff. Sorry, guys. Anyway, well, yeah, so the point is the the point is, he was on the Joe Rogan show. He made a bunch of claims and stuff like that you can check out. You know, like I said, I'm going to end it off. I don't want to get too long in this into the minutia. I think I pushed in, put out some of the stuff that I wanted to put out. Just let me know what you think about it, and make sure you guys share this message. Appreciate you coming through. Peace.